So now let's talk about once we have this postsynaptic response, how do you propagate an action potential? Probably the best way to think about here is that you need to depolarize that postsynaptic membrane. So what I mean by depolarize, remember from membrane potential, a depolarization is moving up or becoming less negative. A hyperpolarization is moving down. So with our depolarization component, we have two things that could happen. Either when we bind to our postsynaptic membrane, we have a sub-threshold event, or we have a threshold event. If you are able to eclipse threshold, you will get an action potential. If you are sub-threshold, even though you stimulated that postsynaptic membrane, you actually will not obtain an action potential. So this threshold is a very important concept to have in mind. Each individual nerve will have a threshold limit, and you need to get enough signal up to that point to reach threshold. And again, once that's reached, you will then propagate that action potential. So let's go through some processes here that will make this more understandable and how we quantify things like subthreshold depolarization or hyperpolarization. This is done by looking at excitatory postsynaptic potentials. We oftentimes abbreviate these EPSPs for short. So there's ways that we can maximize the amount of potential that comes across the membrane. If you have one stimulation, you usually get one depolarization. So maybe a way to get greater amounts of depolarization is use more than one nerve. If you do that, you get a bigger response. Finally, if you bombard it with a number of different axons, bam, you'll get a higher response. And usually when you get that higher response, you can then trigger a threshold event. Another way to do this, besides using multiple axon terminals that will bond up against a particular neuron, is to have them occur very frequently. So you could have one particular axon terminal giving multiple signals really fast. And what that will allow to have happen is to build up membrane potential to, again, hopefully do what? Reach threshold. Because if we can reach threshold, we will be able to develop an action potential. I would like to say that all subthreshold events are positive. Because, we like to stay positive, don't we? We don't like to get too negative on things. But that's, unfortunately, we have to add both the positive and negatives in real life. And that's what we have to do here for excitatory postsynaptic potentials and the opposite, which is an inhibitory postsynaptic potential. So if we look at the positives first, let's take a membrane potential that starts out at minus 70 millivolts. You can see here two green blips. Those are EPSPs, a signal from another nerve telling this particular nerve to fire. At point A, we have not yet reached threshold. In our example here, threshold is minus 55. So no action potential has occurred yet. It would be nice if we got one more of these EPSPs to have us reach threshold, right? Unfortunately, an IPSP just came in, knocked our threshold down, not our threshold, knocked our membrane potential down because it hyperpolarized that particular response. Then we're at baseline for a little bit. We give another EPSP, it gets depolarized further. We're getting close to threshold. Another IPSP just came in and hyperpolarized the membrane. Luckily, the EPSPs didn't give up. They got another couple of hits, and that we're able to move membrane potential up to eventually reaching threshold, and right at B, we got an action potential. And that is what's going on constantly in the brain and throughout many nerves in the body. You're getting all of these signals. Sometimes a signal will cause an event like an action potential, and sometimes they just build up. But you have to remember you need to sum up the total of EPSPs and IPSPs to see if you can reach threshold.